Yeah, danke für die intro. First of all, I can do this talk in English or in German. If there's one person that says do it in English, I'll do it in English. So if anybody wants to raise their hand. Okay, so I'll do it in English. That's fine for me. Hi, I'm Felix. I work at CC Systems. We're a company that does app and web development, but also a lot of cloud infrastructure and cloud migrations. And we do both greenfield and brownfield. Most of the stuff today is about brownfield, like when we come into existing projects and try to improve them and change them. And I'm going to share some experiences that we made over the years of maintaining and modernizing legacy systems. The systems range from small to medium-sized applications, but also to internal tools that have grown wild over the years and can no longer be maintained. But there's also large-scale e-commerce applications with billions of euros of turnover per year. And also, once we did a migration of an IoT system with millions of inserts and a 7 terabyte database. So yeah, lots of different things, lots of different technologies, some of them very exotic. But this talk is not about specific technologies, but more about approaches you can do, tactical or strategic, to incrementally provide value and improve your system over time. And there's lots of entertaining anecdotes about stuff we encountered. Yeah, some of which I wouldn't believe if I hadn't seen it myself. Okay, let's get started. What are we going to do in this talk? We are going to learn how to get an understanding of an unknown legacy system. We're going to look at approaches to incrementally improve it, and we're going to discuss a bit the organizational side of modernization, because it's not just a technical but also an organizational challenge. I think Eberhard talked about this a bit in his opening talk. Yeah. So first of all, let's talk a bit about the term legacy, because sometimes people think legacy means old, but that's not necessarily true. And also new is not necessarily better in my experience. So legacy can mean both Altlast, but also Vermächtnis. So it doesn't have to be a negative thing. And the fact that we are working on it proves that the system provides some value. Otherwise, nobody would be willing to spend money on improving it. So, yeah. And also, I think sometimes when people try to modernize the system, they think, oh, I'm going to use this fancy tool or technology that's going to fix everything for me. Well, spoiler, it's not going to fix your problems. If you have fundamental issues in how you design your system, using a different language or framework won't fix it. So let's look at a case study of two systems that are, that can be considered legacy systems. One of them was started in 2013. It's written in Java, and it still uses Java 1.7, which is from 2011. So never updated. It's around 100,000 lines of code, and there's no CI, there's no CD, everything is manual. And when we came into the project, there were no developers. So there was just the company and like sales and support stuff, and this running system, but nobody maintaining it. And compare this with System B, which was started way earlier, like 10 years earlier, in the early 2000s. It's a lot bigger, it's 1 million lines of code or more, and it uses a recent Java version, so it's updated frequently. There are solid CI/CD practices, and it's maintained by 30 engineers. So the system is older, but it's in a much healthier state. So just because something is old doesn't mean that it's bad or unhealthy. And let's look at the second case study about why new isn't always better. So let's take the system B, again from the previous slide, and compare that to a recently developed system of a similar size, System C. And by the way, those are real systems, but I'm not outing who this is, but those were real systems that we worked on. So this System C was started like 3 years ago, I think, and it's also 1 million lines of code. It's written in .NET. There's CI/CD, It's also actively maintained by lots of people, but it's a big ball of mud since day one because its fundamental design was very complex, and the problem it was going to solve was very easy. But they built a very over-engineered solution with new tools, but the system in the end was unmaintainable. So I think this goes to show that the choice of your language or framework or patterns don't make something work or not work, and they don't make it legacy or not legacy. And I think this is an example of Gell's law in action, which states that complex systems evolve from simple systems, which you can see in system B. It aged over more than 20 years. It started simple, and it got bigger and more complex over time. And that complex systems from scratch tend to not work, like system C, where they had a problem, they thought they know the solution, and they built this huge system which is mostly not live today. So they spent a lot of money on nothing, at least until today. Right, so how do you work with legacy systems? Well, spoiler, there's no silver bullet, there's no do this and everything is perfect. I think you have to put in some work. And in my opinion or experience, the key is incremental changes to your system. And I'm going to show you some specific things that you can do to, over time, improve your code base and at the same time provide value to the customer. So here's a very high-level general way of how you would approach modernization projects. First, you look at the kind of system you have, you do an assessment, then you make a plan of what you want to change and how to change it, and then you execute it. Sounds easy, right? Well, in practice, it looks more like this, because often there's a lot of information missing in this initial assessment phase, because legacy systems often have some lost knowledge. So the system was built many years ago, then developers moved on, and now there's a system, and when you try to improve it, there's certain gaps in your knowledge of the system. And also, the execution takes a lot longer than the first two phases, which is not represented in this image. So I think the lesson is that you have to be able to adapt your approach as you go, but still having some sort of methodology can have some merit. So let's look at how this first step, the assessment, can be done. So one thing that I have done, or that we have done a couple of times, is to, when we get into a new project, we do like a very structured way and try to gather all the information that we can through interviews with developers, users, stakeholders, if we can find them. But also, you can use some domain-driven design techniques, like event storming or domain storytelling. I can't explain those now because I don't have the time, but they're great and there's lots of resources on them. You can also try reading code or documentation, but that's sort of a last resort because the code is often very complex and the documentation is often lacking or incorrect. So I would say focus on the first two, and the third one is a last resort you can try. And when you gather all the data, I think it's important that you collect all your findings in a central place if you can. And what we've often done is have like a central table, like an inventory of all the parts we know of the system. In this case, it's services, but it could be different sizes of units. And then collect data about these units. For example, how critical they are to the business, or what kind of dependencies they have, what technologies they use. And you can use this data later on when you make your plan or when you execute the migration or the improvement to guide which part you want to improve first. And there's lots of stuff you can consider here. I hope it's not too tiny. So stuff you can consider here is who developed the code, if there's any CI/CD in place, if you have access to the source code, because that's not always the case, sadly. Where or how it's deployed, whether the application is stateful. This can be important if you are thinking about migrating to some sort of serverless environment or like Kubernetes, because there your applications can be terminated at any point in time. You can also try to gather information about the system requirements of the system, like how much CPU or RAM does it use. You can also try to find out or define performance requirements or SLAs. You can also look at if you have any monitoring in place. Another part to cover is the data that goes in and out of the service. And this is also relevant for legal requirements sometimes, depending on your domain. And also very interesting, in my opinion, is the known pain points of users. If you have users or developers, those can give you usually some insights into what is wrong with the system. They might not know the solution, but at least they can give you information or hints where to delve deeper. And with all this, you can come up with some sort of overall health rating for your service or unit, and this can guide your modernization efforts. Right. So you can also use automated tools for this. Don't only use them, but you can use them to assist you. For example, there is a tool by Google called Migration Center Discovery Client, which is a command line tool that you can deploy in your on-premise system. And it scans network for virtual machines and for configurations and running processes. And you can use this data to identify gaps in your table. So if you find some virtual machine that nobody knows what's happening there, that's where you have to look. That's where you have to go deeper. I've also used this Microsoft SQL Server Migration Assistant successfully. That's a tool that can help you with, if you have a Microsoft SQL Server, it can help you with understanding how to upgrade it, and also you can find incompatible queries between versions, which would be very difficult manually. But you can install this on your system and have it observe your database for a couple of days, weeks, months, and then look at the insights. And also, I think monitoring is helpful here, like tools like Datadog or the LGTM stack. You can use those tools to gather more data about your systems, if you have them in your systems. Right. Also, I think it's important, or I found it helpful, to sketch or visualize your findings. Doesn't matter which tool you use, like Miro, Excalidraw, Figma, I don't care. But in the projects that I've worked on, these two things, this table of services and some sort of central diagram, is the two things I looked at most over the planning and execution phase of the migration. So it's worth spending some time on this. Right, but with all this said, you will miss stuff. There's always this iceberg effect with legacy systems, at least in my experience. No matter how good you do your assessment. And it has already happened to us twice that a customer approached us. They said they have a backend system, it's working, they want us to build an app. We said, okay, so sure, we can do that, that's what we do. And then they said, we also need some backend support maybe just a bit. And then 2 years later, we spent like a month on the app and the rest of the time stabilizing and modernizing the backend system, because they didn't know that they were sitting on ticking time bombs where the cloud provider was threatening to shut down the database because the version wasn't maintained anymore or stuff like that. So they didn't know what they were sitting on. And yeah, so also there's also always some WordPress somewhere in my experience. And also because the system is, in those cases, it was no longer actively maintained, the employees that were using the software for internal purposes, they had some strange workarounds that they had to develop because nobody could fix the software for them. So it was also interesting talking to them to understand. So they helped us understand the system because they knew these quirks they had to work around. So yeah, be prepared to adapt your plan as you go, because you will discover more as you execute your migration or as you improve your system, and you might have to adapt your plan. Because in many cases, or in all cases, these legacy systems are not built in a single day, but over many years or even decades. And I think it's a bit arrogant to assume you can modernize them in a month or two. It will take a long time because there's a lot of complexity encoded in the system, and you are not going to fundamentally change or improve the system that was built over decades in half a year, no matter how smart you are. And also, just because you have a running system doesn't mean you have the knowledge or tools to rewrite it from scratch. That's a bit of a fallacy that people sometimes have, that they think, oh, I have this huge Java application, I know what it does, let me rewrite it in Go in half a day or like in half a week or something. That's not going to happen, or usually it doesn't happen. And instead, I think you have to incrementally change the system, and because usually that leads to better results than giant steps. And we all know this, at least when it comes to writing new software. But when it comes to modernizing, sometimes we want to do many things at once. But that's not a good idea. So, for example, suppose you have some sort of monolith, and you want to rewrite it in microservices because your organization decided, okay, that's the direction you want to move in. And at the same time, you replace your queuing mechanism with Kafka and also update the Java version. If you do all those things at once, you're likely to fail. And if you fail, you don't know why you failed. So the smaller the steps you take, the lower the risk of failing. And if you fail, at least you know why you failed. I have a real example that I actually did. Here, so I was working on a system that was a monolith. It was written in Java, and there was some SOAP connector for a third-party system, and we were moving it to a microservice. So I moved it to a microservice and rewrote it in Kotlin because I thought Kotlin is better. Let's use Kotlin, and it didn't work. And to this day, I don't know why, but so I thought I was doing two things at once. But in the end, I had to do it twice because my initial Kotlin attempt failed because I think maybe some annotation was behaving differently or it didn't like my data classes, I don't know. So in the end, I had to go back and take the Java code and basically just copy it, and then it worked. So don't try to make giant steps because you're more likely to fail. And I have some examples of small things you can do in your systems that over time will build up and increase the health of your system. And one simple thing you can do, and I think everybody knows this, is whenever you fix a bug in your system, take the time to write a unit test to make sure that you never have a regression and never have this bug again. I think this is an implication of the Boy Scout rule, which states that you should leave things better than how you found them. And there's more things you can do that are simple as this, and individually they seem very insignificant. But in my experience, if you do many of these things over a long time, you can actually make a difference. And also these things, in my experience, have a good return on investment. So you spend small time, but the outcome is very good. Right, so the next small thing you can do is when you can't find a bug, then ask yourself, why is that? What kind of data am I missing? What kind of insights do I need that could have helped me track down this bug? Because if you just give up, then you're not going to find the bug the next time the user reports it to you. So, and I have an example for this. I was working on a system where there was a synchronization with a third-party system. So both systems kept some data. The data must be synchronized. And it was working fine. But like once a month, there was some small issue. And we didn't understand why. So when this first happened, we added some logging because we didn't understand what was happening. So we added some logging for the case where we thought, okay, this is where the issue is, most likely. And then nothing happened. And then like a month or two later, there was another issue. And this time we had some more logging. And we saw some false positives because that's not the issue we were looking at. So we improved some filtering for false positives. And then we forgot about it. And then, like almost a year later, we got another alert. And this time we actually understood the bug and fixed it. And in the end, the bug was very simple. There was just some request parameters that were not the way the system expected it. So it's very simple, but we never would have found it without having this logging in place. Right, so talking about alerts and observability, if you receive alerts, and if you have alerting in your system, which I hope you have, if you receive alerts that don't require you to do anything, then why receive them? So when you receive an alert, you should do one of two things. Either you fix something, and that means the alert was good, or if the alert didn't require you to do something, change the alert, change the threshold, change the receivers, or delete the alert entirely. Another thing you can do when you have a system that is unstable and you notice too late that it's broken, and this is described by the mean time to discovery, meaning that that's the mean time you take to detect faults or issues in your system. If that's too high, then invest time in alerting. Because ideally, you want to know about the issue before the user calls you, hey, I can't order what's going on in your system, I'm very unhappy. So you want to beat the user to discovering the issues. And I have an example of how we achieved this in one system we were working on. So in one system that we were working on, it was a Java application, and it was using some NoSQL as a caching mechanism. And the NoSQL was self-hosted on some EC2 instance in AWS, and it would crash sometimes. And we never noticed when this happened, except when customers called us, hey, the shop is broken. And the tricky part was, we, at the time, didn't have the tools to change the Java system. So we couldn't build monitoring on the inside. We couldn't create alerts from the inside. So what we did was, we added some black box monitoring, which is monitoring from the outside, and we added some job that periodically calls the system on a public endpoint, which we know uses this NoSQL. And when this call fails, the job would report the metric to CloudWatch, and then we would get informed. So this is not the solution I would have built if I had designed the system from scratch, but at the time, I think it was the best we could do to improve it. And then later, when the system is more stable, we can invest in some white box monitoring, which is monitoring on the inside. Right. What else? So the next part is toil. Toil is a term that is from the Google SRE book. And toil is defined as manual work that is repetitive, and it has no enduring value. So it's stuff you have to do, but afterwards the system isn't better, you just fixed something in the short term. And examples of this are like manual deployments, for example, or manually restarting pods in your cluster. And whenever you encounter toil, whenever you have to do something manually as a developer, that's very expensive. If you have to do it over and over again, it's also error-prone. So this is something that you should consider, and you should also communicate this to your clients or stakeholders that you have to do manual stuff. And if you have some toil in your system, consider the cost of reducing the toil versus future toil if you don't fix it. And I have some more examples for toil. One is manual deployments, I already mentioned that, or manually scaling and restarting instances. Another one is if you have to manually do stuff on your database. You don't want to do that for many reasons, but one of the reasons is it's a manual thing and it has no enduring value. It's just a short-term thing you do. So whenever you do something like this, consider creating some sort of automation or at least some sort of way to change it through some sort of UI and via endpoints. And talking about endpoints, if you have to manually call endpoints to do stuff in your system, that's also toil, I think. And we had this in a project where we had to call a bunch of endpoints whenever a new business client was onboarded, which didn't happen often, which is why it wasn't automated. But that was very, like, you had to call it, I think, at least 10 endpoints to create this customer. And in this instance, it was justified because it happened only once a year, and it took like a few hours. So in this case, I think the cost of automating it would have been higher than the cost of doing it manually. But when the business changes and they sign many clients per year, then it's time to automate this. Because you don't want to end up here, because also automation isn't free. So whenever you have a task and you think you can automate it, it costs some time to automate it, and also you have to maintain this automation. And like tools like Kubernetes and Helm and stuff like that, they all do some sort of automation, and that's good, but they also have cost. So you don't run a cluster for free. You need people who maintain the tools in the cluster. And depending on your size of operations, it can be worth the investment or not. And I think the financial term for this is total cost of ownership. So you need to consider the cost of creating the solution, but also maintaining it over the long term. And if the total cost of ownership of automation is lower than the manual approach, then it's a good investment. I also have some anecdotes about some undeployable applications we found over the years. The first one is a Java application. It's always Java. Not always, but very often. And there was no pipeline, and we were the only developers. We just, we started the project. There were no other developers. We were just given the source code and some AWS credentials, and that's it. And we had nothing. And the dependencies were so old that the Maven repository didn't have them anymore. So you couldn't run install anywhere. You couldn't get the dependencies, which is wild. So what we managed was we managed to track down a former developer of the project with the help of the customer, and they were in Australia at the time, and they sent us their .mt folder, a .m2 folder, which is the node modules folder. It's the local repository. So they sent us their copy of the dependencies, and to this day, this .m2 folder is part of the CI. So in the CI, we install the dependencies from this local repository because the Maven Central doesn't have them anymore. And with this, we managed to build a pipeline. And it's crazy, but yeah, at least it works. So I have some notes for this. So yeah, we tracked down the M2 folder from Australia, put it in the pipeline. Yeah. The second example is we had some batch processing in Java, and we had the source code, but we couldn't deploy it. We never deployed it. And there was some problem with it. There was some logging from which we could see that some records being processed were broken, but we didn't know which and why. And we estimated that making it deployable would take a week or even longer, and there was a lot of uncertainty because we've never done it before. And yeah, there was no developer to contact. So what we did was we attached a debugger to the running server in production, which usually you don't want to do. But in this case, it was the financially viable option. And with the debugger, we found the broken record, and yeah, we went to the database and removed it, and then the batch processing was fine. And then later, we had some replay mechanism to recreate the record later. And this is, I've never seen this before, but the reason for this broken record was that, so it was a NoSQL database, and there was a web interface, and for some reason, when you changed an object in the web interface, the Java code couldn't read it anymore. So if you manually do something in the web interface, your application can't process the record anymore. So somehow this happened, and the record got broken. And the insane part is this NoSQL version we were running, documentation was also offline. It was so old, documentation didn't exist anymore. So we were a bit, there weren't many options at the time. So even though I don't like the solution, and I'm not saying attach a debugger to production, everything will be fine. Sometimes you have to do crazy things when working with legacy applications, because the proper solution, like making it deployable, would have taken a long time. And in this time, the batch processing would have been broken. So yeah, it was a bit of a shortcut and not the elegant solution, but it was a practical solution. I have a third example of an undeployable system. It was an internal billing and reporting tool, and we didn't even have the source code. We didn't know about its existence until it broke. So the customer contacted us and said, oh, I have this billing tool. It worked yesterday, it's broken today, what happened? So we knew it was running in AWS most likely, and we managed to track it down. So we found this EC2 instance where it was running, and we connected to it, and we found some source code. It was PHP, and the code sounded like it was the application that was broken. And we managed to find the files that were processing the requests. And what we found was that the report was accessing the database, and it was using a hard-coded start date for its report generation. And the data got too large. So it was always saying, give me all the data since, I don't know, 2015. And at a certain point, the data was too big. So the system broke. So what we did, and again, I'm not saying do this at home, but in this case, it was the best solution we could do because we didn't even know how to deploy this. We just changed the value on the running system, and then it worked again. So it's not a long-term solution, but sometimes you have to do both. You have to fix the bleeding, to fix the system immediately, and then you have the time to invest in a proper solution. Right, so crazy stuff. Yeah, so in summary, lots of reverse engineering with legacy systems and lots of creative problem solving. So let's summarize briefly. We've seen that when you fix a bug, you should also add a test. When you can't fix it, invest in monitoring. When you get alerts that are pointless, get rid of them. When it takes too long to detect the outages, improve your alerting. And whenever you have some sort of toil, consider the cost of removing it. I think that's a good summary of the actionable things you can do in your system. I want to take the remaining time to talk briefly about the organizational challenges that come with software modernization projects, because it's not only about technology, but it's also about organizations. And nobody's telling you to improve software for fun. Usually it's an investment. So usually there's some reason why a business or organization wants to change software. And usually it's because of legal requirements or because they want to make changes, but it's taking too long, or it's too unstable, stuff like that. So usually there's some sort of goal that you want to achieve. It's not just for fun, right? I think I have time for this. So one thing you can do is try to use Conway's law to your advantage. Conway's law, I think everybody knows. It states that organizations tend to build systems that reflect their communication structure. And people usually take this to mean that if you want a certain architecture, that you should change your organization to get the architecture. But that's often not practical or feasible or desirable. And also, depending on what rank you have, you can't just really go and organize the organization if you want. So a different take on this is that you should look at your organization and ask yourself, what kind of architecture would suit my organization? For example, if you have a small to medium-sized team or organization, then the organization will very likely have strong coupling among its members. So if you have a team of like 5 people or 10 people, everybody knows everybody, they all talk to each other, and I think if that's your team, then the suitable architecture is a monolith, because in the monolith, also all the services know each other and talk to each other. And if you have a large organization, then you have the need to, or you very likely have the tendency to create interfaces for communication in your organization, like middle management and POs and stuff like that. And if you have this, then you can also consider having the same interfaces in your microservices or in your modular monolith. So look at your team and ask yourself, what kind of architecture would suit my organization? Another important factor is to prioritize your modernization efforts, because you can't do all things you want to do, and sometimes you have to leave certain parts the way they are, even though you would like to make them better. And I think you should try to focus on your core domain, which is a domain-driven design term for the stuff that sets you apart from your competitors. It's your core area of business. You can also consider looking at the hot path, like the code that's run most frequently, or the code or the part that yields money, because it's an investment and you want to make sure that you have your, like the part that generates money, that should be stable and in a good condition. And you can use the data from your assessment, from the assessment in the beginning, like this table, to understand this and guide your modernization efforts. Because you know your criticality, you know your dependencies, so you can make decisions about what parts to modernize. And when you modernize, you should try to not fix things that aren't broken. Because lots of times I see a system and I know the code is ugly, I want to make it better, but if it's working, why change it? And if you change it, don't try to make it perfect, but make it good enough. Because often you can achieve 80% of the outcomes with 20% of the efforts, which is the Pareto principle. And it's up to you to prioritize how you spend your time. And you have to consider the opportunity costs of modernizing. So when you modernize one part, you might not have the time to modernize another part. So you have to make a decision which parts to modernize. And you can also ask yourself, what's the cost of not modernizing one part? So if it's not critical to your business, maybe some parts can be in a quote-unquote bad condition, but that's fine, and you know about it, but you make a conscious decision to leave them as they are because they're good enough. Right, I have some more slides and then I'm almost done. So I think the most important part is that when you modernize, you should focus on generating value, because modernizing is not just a goal itself, but it's usually an investment and you want to achieve something. And we all like to build cool stuff and nice architectures and efficient algorithms, but in the end, the customer doesn't care, right? If your algorithm has n log n compared to n squared complexity, nobody cares, given it's fast enough. Or if your source code uses amazing TypeScript features, nobody cares. Your shop has to work, right? But we, as engineers, like to build these cool algorithms, and we have the urge to make these nice things. But yeah, we have to face the reality that the technical excellence, while it's important, I think is not as important as creating value to the customer. And this applies to new products, but it also applies to existing products. And focusing on adding value with incremental steps can help you guide modernization. And I think it can also help you avoid bike shedding, like which frameworks to use or which architecture or stuff like that. Sometimes those decisions are important, but it has to be about value for the customer and not about I want to use this and that pattern because I heard it's nice. Right, so 2 more slides and then I'm done. I think another important part is that you should track your time to understand how much time you spend on, for example, toil or like this like manual part, so you can communicate cost to the upper management and tell them, like, okay, we have this manual overload, we need some budget to fix it. And in the end, it's a marathon, not a sprint, because the system was built over a long time and you're going to maintain it for a long time. And I think it's important to set goals so that you can set expectations and move in the right direction. And also important is to celebrate achievements when you reach a goal. And I'm not talking about like giant stuff, like after 2 years, have a big launch and have a party, but also like small stuff, like when your coworker refactors some ugly code, tell them that it was a good job, stuff like that, like small things. Because in the end, we all contribute to creating the environment that we all want to work in. So, yeah, I hope I didn't lose you. I hope you're still awake. So, closing thoughts, brief summary. We learned that old is not legacy and new isn't better. We learned a few approaches to understand the system and that you need to define where you want it to be. We looked at some approaches to incrementally improve the system over time, and that those can build up and add a lot of value. And you need to prioritize when you modernize, because you can't do all things, and you can never make it perfect. And it's important to consider organizational business sides. I have some book recommendations if you want to read more about this. There's Kill It With Fire. It talks a lot about the organizational side. There's Working Effectively with Legacy Code. I think itself is legacy. It's like 20 years old, but it still has some relevant concrete technical steps you can do. There's the SRE book from Google, which has good practices for running large-scale systems. And also for the domain-driven domain people, there's the domain-driven transformation book, which is also a good book. And I leave you with a quote that it's from Da Vinci. He said, "Software is never finished, only abandoned." Well, okay, he actually said art is never finished, only abandoned. But I think it also applies to software, because both art and software, it's a continuous effort required, and perfection is impossible, no matter how hard you work. And the work is, in a sense, Sisyphean, so it's Sisyphus Arbeit. But I think it's still worth doing. So I say let's not abandon our systems and work on them. Right, thank you.